All right, so 1 through 3, I got the question, determine if x and y show inverse variation, direct variation, or neither. Right, so remember, inverse variation is going to be an equation of y equals k over x, and direct variation is going to be an equation in the form of y equals k times x. So we look at number 1, which is x equals 8y. In order to determine what kind of variation it has, we have to get it into y equals form. So I'm going to start by solving for the y. So move the 8 over, which leaves us with y equals x over 8, which in this case it doesn't fit inverse variation because the x should be in the denominator. And it's actually kind of tricky because if you look at it, you think, well, it doesn't fit direct variation either because it's x over 8. But what you want to look at is that x over 8 is the same thing as 1/8 times x. So then that's going to be direct variation. A2, we got yx equals 12. Once again, you need to get the y by itself. So divide by x on both sides. You get y equals 12 over x, which now you got the x in the denominator with a number on top, which would be inverse variation. And 3, y plus 4 equals x. And you get y by itself, so we subtract the 4. It's going to give us y equals x minus 4, which that's not a number divided by x or a number times x, it's a number subtracted from x. So that's going to be neither. It doesn't fit inverse or direct variation. All right, and number 4 tells us that x and y vary inversely. Use the given value to determine the value for y when x equals 4. And then it tells us that x equals 12 when y equals 3. So we're using inverse variation, y equals k over x. So based on this, our x equals 12 and y equals 3. So if I plug in 3 for y and 12 for x, we solve for k and multiply by 12 on both sides and find out that our k value should be 36. So if our k value is 36 when x equals 12, now we can plug that into an equation of the form of y equals 36 over x. And we want to know what the y value is when x equals 4. So when x equals 4, that gives me y equals 36 over 4, which is going to be 9. All right, number 5 tells us that z varies jointly with x and y. So that would be an equation in the form of z equals kxy, the joint variation. Then we want to use the given value to determine the value for z when x equals 3 and y equals 6. So they tell us that z equals 24 when when x equals 4 and y equals 2, so x times 4 times 2. So it's going to be 24 equals k times 8. Then to get k by itself, we divide by the 8. So our k value is 3. So that means that the basic format of the equation should be that z equals 3 times x times y. We replace k with the 3. And now it gives us values for x and y. X equals 3 and y equals 6. So z is going to equal 3 times 6. So 3 times 3 will be 9 times 6. It's going to be 54. All right, so then number 6 starts graphing. Gives us an equation y equals 4 over x. And it's a pretty basic equation. The format of the equation we're following here is something in this format: y equals a over x minus h plus k. And when we have an equation in that format, our asymptotes, remember, are the line x equals h and y equals k. So in this case, we don't have anything subtracted from the x in the denominator, so there's no h, or we would assume that that was minus 0, so our h would be 0, and we don't have anything added outside the fraction, so we can assume that that's like plus 0, so our k value would be 0. So the first thing we do when we graph these type of equations is we want to find the asymptotes and get those listed there. Which in this case, we're looking at x equals 0 and y equals 0 for asymptotes. So you got the axes that are acting as our asymptotes. And so then when we want to graph it, we want to pick 2 points to the left of the asymptote, of the vertical asymptote, and 2 points to the right. So since our asymptote is at x equals 0, then we can use -2 and -1 on the left side, and +1 and +2 on the right side. It's going to give me 4 over -2, or -2 for my y, 4 over -1, -4 for the y value, and we can do 4 over +1, so we +4, and 4 over 2, it's going to be +2. So when we go to graph it, we got the point -2, -2 there, and -1, -4 there. So we go from the asymptote to through the points, and then curve off at the other asymptote. So we got the graph that looks something like that on that side. And on the other side, we got 1 positive 4 and 2 positive 2. So same idea over here. Start at the asymptote, go through the points, and then curve off before you hit the other asymptote. So the graph should look something like that. Right, so then the next one gives us an equation of y equals 4 over x minus 2 plus 3. So this is still in that format that we had up here of y equals a over x minus h plus k. So we can identify our h and k so we can get our asymptotes. So the h value is going to be the 2 right there, and then the y value or the k value is going to be the 3 over here. So our asymptotes is going to be the line x equals 2 and the line y equals 3. So if I put my asymptotes into place at x equals 2, I got a vertical asymptote there, and y equals 3. Horizontal asymptote there. So to pick my x values with my asymptote at positive 2, I'm going to use 2 to the left and 2 to the right. So we're going to go 1 and 0 to the left and 3 and 4 to the right. So we're doing 0, 1, 3, and 4. 4 over x minus 2 plus 3. 1. So if we got a 0 there, it's going to be 4 over 0 minus 2 plus 3, or 4 over negative 2, which would be negative 2 plus 3, which gives us a 1. Put in a 1 there, we got 4 over 1 minus 2 plus 3, or it's 4 over negative 1 plus 3, or negative 4 plus 3, which would be negative 1. Plug in a 3, so it'll be 4 over 3 minus 2 plus 3. That would be 4 over 1 plus 3, or just 4 plus 3, which is 7. If we plug in a 4, we've got 4 over 4 minus 2 plus 3, or that's 4 over 2 plus 3. That would be 2 plus 3, which is 5. So we got the point 0, 1. 0, 1, and then 1, negative 1. So we're going to have a graph that looks like that on the left side. Then we got the point 3, 7 and 4, 5. So 3 up to 7, 1, 2, 3, 4. So 3, 7 and 4, 5. that. So that's going to look similar to that there. All right. So then the next one for 8 in the form of x minus 1 or y equals x minus 1 over x plus 2, which this is a different format than the H and K format. This is in the format of equation in y equals ax plus b over cx plus d. And so our asymptotes in this format are going to be whatever value makes the denominator equal 0 is going to be our vertical asymptote. And then y equals a over c is going to be our horizontal asymptote. So for x, we've got whatever makes cx plus d equal 0. Right? So to find our asymptotes here, we're going to take the denominator, x plus 2, set it equal to 0. Solve for the x. So x equals negative 2. And then for y, it's a over c, which is the numbers in front of the x's, the coefficients, which in this case, neither one of them has a coefficient, so we just assume those are 1s. So that's 1 over 1, or just y equals 1. So we can get our asymptotes. So we got our asymptotes are x equals negative 2. So we're going vertical through negative 2. If I can do that straight this time. And then we've got y equals 1 for our horizontal asymptote. So when I go to pick values to plug into the equation, we're going to use the same idea. 2 x values to the left of the vertical asymptote, 2 x values to the right. So to the left of the vertical asymptote, it's going to give us negative 4 and negative 3. And to the right, we're going to have negative 1 and 0. And that into x minus 1 over x plus 2. So we got negative 4 minus 1 over negative 4 plus 2. So be negative 5 over negative 2. So that'd be positive 5 halves. For negative 3, negative 3 minus 1 over negative 3 plus 2. So negative 4 over negative 1, which would be positive 4. We got negative 1 minus 1 over negative 1 plus 2. So negative 2 over 1, or negative 2. And for 0, 0 minus 1 over 0 plus 2, it'll be negative 1/2. 5/2 is the same thing as 2.5, right? So plot our points. At -4, we're at positive 2.5. 2.5, somewhere about there. -3, we're at 4. Be somewhere in there. So from the asymptote through the points, curving off before the other asymptote. And then for the other side, we've got -1, -2. -1 down to -2, and 0, -1/2. Somewhere about there. So from the asymptote through the points, and curve off before you hit the other asymptote. So the graph's going to look like that. So then number 9, 10, and 11, we're just simplifying if we can, it says. So we got 4x squared over 2x squared plus 3x. So to simplify it, we're going to factor anything out that we can factor to make it simpler so we can see what might cancel out from the top and bottom. And so we can just have 4x squared on the top. On the bottom, we got 2x squared plus 3x. The 2 and 3, nothing in common we can pull out of those. But the x squared and x, we got an x we can pull out. So x times 2x plus 3. And so when we have a x by itself there, you could look at the top and say, well, I could separate my x's. 4x times x over x times 2x plus 3. And you can see you can cancel one of your x's out. And so as simple as it gets is 4x over 2x plus 3. Number 10, x squared minus 16 over x squared plus x minus 12. So to simplify those, we need to factor them to see if they have anything in common top and bottom. Okay, so x squared minus 16 is a difference of two squares. So you take the square roots of the two values and add them and subtract them. So the square root of x squared is x. Square root of 16 is 4. So we're going to have x plus 4 times x minus 4. Now for x squared plus x minus 12, look at that last number there. Find out what factors of that last number will add up to equal positive 1. So it's a negative 12, so one's got to be positive and one's got to be negative. So 4 and negative 3 would add up to equal positive 1 to be in front of the x there. So that's going to give me x plus 4, x minus 3. So now I can see that I've got a x plus 4 on the top and the bottom. So I can reduce that to x minus 4 over x minus 3. And number 11, x squared minus 2x minus 8 over x squared plus 3x minus 4. Okay, so we got two separate trinomials, so we've got to factor each one. So if I look at x squared minus 2x minus 8, last number is negative 8. And so we got to have a positive and a negative that add up to negative 2. So that means your bigger number has to be negative for it to end up with a negative. So negative 4, and positive 2 would add together to give us negative 2. So the top is going to factor to x minus 4, x plus 2. The denominator, we've got x squared plus 3x minus 4. Once again, that last number is negative, so got to have a positive and a negative to add up to positive 3. And in this case, the bigger number has to be positive. So that would be 4 and negative 1 would add up to equal 3. So that means that I've got x plus 4, x minus 1. So when I look at the top and bottom there, I've got x minus 4, x plus 2 on top, x plus 4, x minus 1 on bottom. I don't have anything that's alike, so I can't cancel anything out. So in this case, it's not possible to simplify that one. X squared minus 2x minus 8 over x squared plus 3x minus 4 is as simple as it goes. And number 12 through 22, now we're just performing the mathematical operations and simplifying it if possible. So 12 is 12 times x squared times y over 5y squared times 2xy over 3x squared. So I can go ahead and multiply straight across on this because it's just one term top and bottom on both of them. So 12 times 2 on the top, it's going to give me 24. X squared times x, it's going to be x to the third, adding the exponents. And y times y, it's going to give me y squared, which is going to be over 5 times 3, which is 15. And then x squared, y squared. Now, we've multiplied it. Now we simplify it if we can. Get 24x cubed y squared. So it's, and 24 over 15. Both of those terms will divide by 3. So I can reduce that to 8 over 3, or 8 over 5, I mean. So 8 over 5. And then x to the third over x squared. So x squared is going to take away 2 of those out of the 3, leaving us 1 there. So x to the first, or x on top. And then y squared over y squared is going to cancel each other out. So you can have it 8x over 5 or 8/5 x. Either one would be acceptable there. All right, so number 13, I'm looking at still performing operations and simplifying. Now we got x squared plus 2x minus 3 over x plus 2 multiplied times x squared plus 2x over x squared minus 1. So we're going to need to go ahead and factor what we can factor. The denominator of that first one is about as simple as it can get, but we can factor x squared plus 2x minus 3. Look at that last term, negative 3, and the factors of negative 3 that'll add up to positive 2. One's got to be positive and one's got to be negative. So we're looking at 3 and negative 1. Add those together, that'll give us 2. So that gives us x plus 3, x minus 1 over x plus 2. And then if we x squared plus 2x, we got x's in both terms. So we can take that x out. That'll leave us x plus 2 over, and then x squared minus 1. We've got to recognize that it's a difference of two squares. X squared is a perfect square, 1's a perfect square, so you take the square roots of those and add them and subtract them. So that's going to be x plus 1, x minus 1. And cancel out what we've got in common. So we got x minus 1, x minus 1, top and bottom, x plus 2, x plus 2. Cancel each other out. And so then that's going to give us x times x plus 3 over x plus 1. $14, 48 x squared over y divided by 36 xy squared over 5. So first thing we do, it's a division. So when we divide fractions, we got to flip it over and multiply. So that's going to become 48x squared y times 5 goes to the top, 36xy squared goes to the bottom. Now it's multiplication. We can multiply straight across. 48 times 5 is going to give us 240 x squared over 36 x, and then y times y squared is going to be y to the third. So 240 and 36 both divide by 12. 240 divided by 12 is going to be 20. And then 36 divided by 12 is 3. So we got 20 over 3. X squared over x. When you're dividing by the same base value, you subtract the exponents. So it's going to be x to the 2 minus 1, or just x. And then there's nothing to go with the y to the third, so it's going to stay on the bottom. So on to 15. 15 is division again, just a little more complicated. So x squared over x squared minus 1 divided by 3x over x plus 1. So it's division as with fractions, so first thing to do is rewrite it as a multiplication. So x squared over x squared minus 1 times x plus 1 over 3x. And really the only thing that will factor is that the x squared minus 1 right here. Once again, it's a difference of two squares. So we're going to factor it down to x plus 1, x minus 1. So that's going to give us x squared over x plus 1, x minus 1 times x plus 1 over 3x. So the x plus 1s will cancel each other out. And then your x squared with your x will cancel out one of those x's. Take that down to 1. So it's going to give us x over 3 times x minus 1. Alright, number 16. It's a multi-step. X squared minus 5x minus 14 over x squared minus 6x minus 7 times x squared minus 4x minus 5 divided by x squared plus x minus 30 over 2. All right, so we got a lot of stuff that we can factor. We've also got a division there, so first step is rewrite it so that we get rid of the division and turn it into multiplication. So x squared minus 5x minus 14 over x squared minus 6x minus 7 times x squared minus 4x minus 5 times 2 over x squared plus x minus 30. And so then we've got 4 trinomials we need to look at to factor. So we look at x squared minus 5x minus 14. Look at the last term, negative 14. And for the factors, they'll add up to negative 5, which will be negative 7 and 2. We can add a negative 5. So that's going to give us a numerator there of x minus 7, x plus 2. Alright, the denominator, x squared minus 6x minus 7. Like that last term, negative 7. Factors that will add up to negative 6. Going to be negative 7 and 1. That's negative 6. So that's x minus 7, x plus 1. And moving on to x squared minus 4x minus 5. Factor it. Factors of negative 5, that'll add up to negative 4. It's going to be negative 5 and positive 1. Just negative 4. So that's going to factor to x minus 5, x plus 1. And multiplying that times 2 over factor x squared plus x minus 30. Factors of negative 30, they'll add up to positive 1. Got to be positive and negative, so it's going to be positive 6 and negative 5. Add those together would give you 1. So x plus 6, x minus 5. Now we look for what we got in common. We got an x minus 7 over x minus 7, x minus 5 and x minus 5, and x plus 1 over x plus 1. Put that together, we got 2 times x plus 2 over x plus 6. That's all that's left. Alright, number 17. We are adding now. So in order to add or subtract, we have to have a common denominator, which in this case we actually do. Both of them are 4x for the denominator, so we can just add those straight across. 7 plus 9 is 16, and once you have a common denominator, it doesn't change. So we got 16 over 4x, or 16 divided by 4 would give us 4 over x. All right, 18. And that subtraction here, 2x over x minus 3 minus 1 over x minus 3. So we already have a common denominator. They're both x minus 3. So all we have to do is combine those together. 2x minus 1, they're not like terms. So we just write them as 2x minus 1, and x minus 3 is the common denominator, so it doesn't change. And that's as far as that one will go. All right, 19. We got 3 over x plus 5 minus 4 over x plus 1. So if we look at those two, looking for the common denominator, you look for what they have in common, which x plus 5 and x plus 1 are two completely different items, so they neither one have anything in common. So our common denominator is going to be made up of just what each one of them is made up of. So the least common denominator is going to be x plus 5 times x plus 1. So to get that common denominator, we're going to have to multiply the one on the left by x plus 1, top and bottom. And then the one on the right, we're going to have to multiply by the x plus 5, top and bottom. So put those together. X plus 1 times 3, we're going to distribute the 3. So it'll be 3x plus 3 over x plus 1, x plus 5, minus distribute the 4. So it'll be 4x plus 20 over x plus 1, x plus 5. So we're taking 3x plus 3, subtracting 4x plus 20. So we got to subtract everything that's in that numerator. So technically that's going to be 3x plus 3, distribute the negative. So it's going to change the sign of everything, minus 4x minus 20 over x plus 1, x plus 5. Combine those together. 3x minus 4x is going to be negative x, and 3 minus 20 is going to be negative 17 over x plus 1, x plus 5. Alright, so then number 20, we're adding x over x minus 1 plus 3x over x squared minus 1. So in order to figure out the common denominator, we need things to be factored if they're not already factored. So x minus 1, that's as factored as it gets. X squared minus 1, though, once again, is a difference of two squares. So that's going to factor to x plus 1, x minus 1. So we can rewrite this as x over x minus 1 plus 3x over x plus 1, x minus 1. So x plus 1, x minus 1 is going to be our least common denominator. So for 3x over x plus 1, x minus 1, we don't have to do anything to get the denominator. But the left one, x over x minus 1, we're going to have to multiply the top and bottom by x plus 1. So multiply by x plus 1 on the top. That's going to give us, distribute that through, x squared plus x over x plus 1, x minus 1, added to 3x over x plus 1, x minus 1. Add those together, x squared plus x plus 3x, and give me x plus 4x over x plus 1, x minus 1. So that was 20, now 21. On 21, we are looking at 7 over x minus plus 11 over 2 over 3x minus 2. So this is a complex fraction. So first thing we need to do is work to get the parts of the numerator and denominator combined. So we've got to have a common denominator. And so on the top, that's 11 over 1. So 7 over x plus 11 over 1 1 times x would give us x for the common denominator, so I'm going to multiply the top and bottom by x to get an x in that denominator. So that's going to give me 7 over x plus 11x over x. And then on the denominator, I got 2 over 3x minus 2 over 1, basically. 3x times 1 will give us 3x for the common denominator, so I'm going to multiply top and bottom by 3x. And so that's going to give me 2 over 3x minus 6x over 3x. So we can go ahead and combine those. 7 plus 11x. It's going to be what we got. 7 plus 11x over x over 2 minus 6x over 3x. So now, still a complex fraction. We got one term on the top, one term on the bottom. So we're basically dividing by a fraction. So we're going to rewrite that as a multiplication. 7 plus 11x over x times 3x. Or when we change division to multiplication, we flip it over and multiply. 2 minus 6x. So that's going to allow us to cancel out an x on the top and bottom there. And we got 3 times 7 plus 11x. So 21 plus 33x over 2 minus 6x. That's about as good as it gets there. Alright, 22. We got 3 over x squared minus 9 minus 2 over x plus 3, and all of that is over 1 over 6x minus 18. So on the top we need to combine those two fractions together. So in order to do that, since it's a fraction, we have to have a common denominator. And x squared minus 9, that's a difference of 2 squares. X squared has a perfect square root, 9 has a perfect square root. So we can rewrite it as those added and subtracted together. So x plus 3, x minus 3, minus 2 over x plus 3. That's 1 over 6x minus 18. So common denominator on the top, you got x plus 3, x minus 3. The one on the right has x plus 3, so it needs the x minus 3. So multiply the top and bottom by x minus 3. So it's going to give us 3 minus 2 times x minus 3. So 3 minus 2x minus 6 over x plus 3, x minus 3 over 1 over 6x minus 18. So we can go ahead and simplify that a little bit. That's going to give us negative, rewrite that, 3 minus 2x plus 6 over x plus 3, x minus 3, over 1 over 6x minus 18. So we can simplify the top a little bit more. 3 plus 6 can be 9 minus 2x over x plus 3, x minus 3. 1 over 6x minus 18. So now we've got a division. Now we want to change it to multiplication. So 9 minus 2x over x plus 3, x minus 3. We're going to multiply that times 6x minus 18 over 1, flipping that fraction from the denominator to multiply it. And so now we've got to recognize that we got x plus 3, x minus 3 in the denominator here. The numerator is 6x minus 18, but we can actually factor that to get take a 6 out of there. And if we do that, that's going to leave us with 9 minus 2x over x plus 3, x minus 3 times 6 times x minus 3 over 1. That allows us to cancel out the x minus 3's. So now we got 9 minus 2x times 6. 6 times each part of there. So that's 54 minus 12x over x plus 3. So that's that one. Now on to 23, 24, and 25, which are all about solving. So we've got 3x over x minus 2 equals 1 plus 6 over x minus 2. So technically the 1 is over 1. So what we want to do here is figure out what our common denominator would be and multiply everything by that common denominator. So we got x minus 2, 1, and x minus 2. So the common denominator is going to be x minus 2. So I'm going to take both sides of that equation now. I'm going to multiply them by x minus 2. So that's going to give me 3x times x minus 2 over x minus 2 equals x minus 2 over 1 plus 6 times x minus 2 over x minus 2, which then this will allow me to cancel out x minus 2 over x minus 2 and x minus 2 over x minus 2. Now I can rewrite this as 3x is equal to x minus 2, because x minus 2 over 1 is just x minus 2, plus 6. So I can move the x over. Now it gives me 2x equals 4. When I combine negative 2 and 6, that gives me 4. Divide by the 2. I get x equals 2. Now on these, when we're solving, we need to also go ahead and check, make sure that those actually work. So we're going to do 3 times 2 over 2 minus 2 equals 1 plus 6 over 2 minus 2, which is going to give me 6 over 0 equals 1 plus 6 over 0. And now that I've got these zeros in the denominator, those are undefined. And so 6 over 0 is not going to equal 1 plus 6 over 0. So that means that 2 doesn't work, and ultimately we have no solution because that solution didn't work. It gave us undefined values. All right, number 24. I have 2 over 2x plus 5 plus 3 over 2x minus 5 equals 5x plus 5 over 4x squared minus 25. So we need to come up with our common denominator. So first thing we need to do is factor the denominators if we can to see what we've got in common. And we got 2x plus 5. Nothing we can combine or factor out of that. 2x minus 5. Nothing will factor out of that. Then we look at 4x squared minus 25. 4 has a perfect square root. 25 has a perfect square root. And so does x squared. So once again, we're finding that pattern of a difference of two squares. And so the square roots of that added together is going to be 2x minus 5 and 2x plus 5. 2 being the square root of 4 and 5 being the square root of 25. So I'm going to rewrite this. 2 over 2x plus 5 plus 3 over 2x minus 5 is going to equal 5x plus 5 over 2x minus 5, 2x plus 5. So now we should be able to recognize 2x minus 5, 2x plus 5 would be our common denominator. So we're going to multiply everything by the common denominator. So I'm going to multiply the left side by 2x minus 5, 2x plus 5. Multiply the right side by 2x minus 5, 2x plus 5. So this gives me 2 times 2x minus 5, 2x plus 5 over 2x plus 5 plus 3 times 2x minus 5, 2x plus 5 over 2x minus 5 equals 5x plus 5 times 2x minus 5, 2x plus 5 over 2x minus 5, 2x plus 5. Now, cancel out everything that we have in common top and bottom. So that's 2x plus 5 there. 2x minus 5 will come out of the next one. The next one, 2x minus 5 and 2x plus 5 are going to cancel out. And so that leaves us on the left 2 times 2x plus 5. Or multiply that through, that's going to be 4x minus 10 plus 3 times 2x plus 5. Distribute that through. That's going to give us 6x plus 15 equals, and all we got left here is 5x plus 5. So combine our like terms. 4x plus 6x will be 10x. Negative 10 plus 5 plus 5 is going to equal 5x plus 5. So I'm going to subtract the 5x from both sides. So 5x plus 5 equals 5. And move the 5 over, subtract 5. So 5x equals 0. And divide by 5. So we get the answer x equals 0. So then we need to go ahead and check. Make sure it doesn't give us an undefined value or some other problem that doesn't work. So it's going to be 2 over 2 times 0 plus 5 plus 3 over 2 times 0 minus 5 equals 5 times 0 plus 5 over 2 times 0 minus 5, 3 times 0 plus 5. So we'll take those zeros out. It's going to give us 2 over 5 plus 3 over negative 5 equals 5 over negative 5 times 5. That will simplify to actually 2/5. That 3 over negative 5 will be the same thing as minus 3/5 equals 5 over negative 25. And so 2 minus 3 is going to be negative 1 over 5. And 5 over negative 25 is going to simplify to negative 1/5. So that actually works. So x equals 0 will work as an answer. All right, then lastly, number 25. Got 7 over x plus 3 equals x over 4. So here we got two fractions set equal to each other, so we can actually solve this one a little differently. We can cross multiply just like they're a proportion, and that's going to give us 7 times 4 equals x squared plus 3x, or that'll be 28 equals x squared plus 3x. Now we'll move the 28 over, minus 28, because we got a quadratic, so in order to solve it, you've got to get it equal to 0. So it's going to give us 0 equals x squared plus 3x minus 28. Now to solve a quadratic, we factor it, set the factors equal to 0 if possible. So we're looking at negative 28, looking for factors of negative 28 that will add up to positive 3, which would be positive 7 and negative 4. Add those together, it'll be positive 3. So that's going to factor to 0 equals x plus 7, x minus 4. Now once we got it factored, we take each part, set it equal to 0, so x plus 7 equals 0, and x minus 4 equals 0. Move the 7 over, so we got x equals negative 7, or add the 4, we get x equals positive 4. So x equals negative 7 or x equals 4. Once again, we still got to check it though. So we got two answers to check this time. So if I do x equals negative 7, that's going to be 7 over negative 7 plus 3 equals x over 4. And that's going to give me, or I forgot to plug in the negative 7 over here for this x, so that's going to be negative 7 over 4. Simplify those down. It's going to be 7 over negative 4 equals negative 7 over 4. Or since there's one negative there, that's the same thing as negative 7/4 equals negative 7/4. So that works. So the answer is good. Then if we do x equals 4, plug it in for the x's, and we're going to have 7 over 4 plus 3 equals 7 over 4. So plug those together. 7 over 4 plus 3 is 7 over 7. Oh, and I plugged in 7 instead of 4 there. Should be 4 over 4. So 7 over 7 equals 4 over 4. Or those simplified to 1 equals 1. So that works too. So both of those are going to stand as our solutions. Alright, so that completes the review. So hope you take a little bit of time and study this and do well on this test. Good luck.